Hello and welcome back. In the last couple of videos we've been looking at functions. First, using functions defined by others, and then defining our own functions. In this video we're going to transition to real programming where we store our programs in a file for later use. The big problem with defining functions in the shell, which is what we did last time, is the functions that we define are transient. If we want to come back to them next week or next year, we have to type them back in again because there's no way of storing the stuff that we type into the shell. So let's just do a quick recap of how we would define our own function in this shell. Let's say we want to write a function to calculate the cube of a value and return the cubed value. I can use the keyword def to define a new function. The name of the function is cube. It's going to receive a single argument within the parameter x, and when I type my colon, it's ready for the body of the function to be typed in. So 4 spaces, and the value that's returned by my function cube is x raised to the power 3. I hit return just to confirm that I'm finished with my function. I give a blank line, and now the shell knows about this new function cube. So I can say what's the cube of 3, and the shell automatically prints out the result of any expression that gets executed. This expression that I'm typing right now is the result of calling the function cube with the argument 3 passed in. So we see 27, which is exactly what we'd expect, right? And cube of 54 is that large number there. Okay, so defining functions is fairly easy, but if we want to edit our functions, run the program later, come back to it in future years, or reuse parts of a program, we want to have it stored away in a file, and that's what we're going to do in today's video. To write a program using Wing IDE 101, we use this top pane up here. This is where we can type a series of statements into a Python program and store it for later use. So I have a file that I've already typed into. It's called Fahrenheit.py. I saved it using the usual file menu and saving options that you're familiar with from other applications. So here's the program over here. It contains a single function definition, def Fahrenheit degrees C. So the name of the function that I've defined is Fahrenheit. It has a single parameter, so it receives a single argument, and that goes into a parameter called degrees C. What happens is we calculate a new local variable. I'll talk about this very shortly in the upcoming slides. And we assign to that local variable degrees f the value of computing 9 divided by 5 multiplied by the parameter plus 32. So that does the conversion from degrees C to Fahrenheit. Degrees f then contains the Fahrenheit version of the parameter value. And we then hand that back. We return degrees f. Okay, so we've defined our function. That's the complete definition of the function. But in our program, we want to call the function. So for instance, if we want to print out the result of calling Fahrenheit passing in 0 degrees C, that's what this program will do. So in order to run our program, we press the green arrow here, and what we'll see is down here the output will appear in the shell. Okay, so I run it. What's happened is the shell has restarted. It's executed everything in this program here, which includes defining the function Fahrenheit and running the statement at the end that calls that function. Okay, so we see that 32.0 is the equivalent of 0 degrees C. Having run the program, the function Fahrenheit is available in the shell, so I can call it down here. If I could type Fahrenheit 100. And what will happen, remember the shell executes the statement and prints out the result. So I'll see 212 there. So the shell has automatically printed out the result of executing this. This is one possible point of confusion for you. The shell automatically prints out any result that's yielded. So I could ask for print Fahrenheit of, say, 200, and we'll see a value printed out. So it looks exactly the same whether I print it or whether I just call it directly, but that is because the shell automatically prints any result that's yielded by a statement. That's not the same in a program. So if we run this again, we'll see we're restarting the shell. It's printed out the value 32, but if we just run this instead in the program, you might think that's going to have exactly the same effect, but what we'll see this time is running the program, nothing appears. And that's because this value has not automatically been printed. Automatic printing is just a quirk, if you like, of the shell. It's not a feature of the language. So if we want to be able to see the result of the output, and when we're programming, we have to do the print explicitly. And we can, of course, add a multitude of statements here, as we have in the program on the right. We can say, print out the Fahrenheit of 0, print out the Fahrenheit of 200, and we could have some more if we wanted. Let's do a couple more. And let's do 451.0, and we'll leave it there for now. So I'm going to cut that one out. Let's run that. We should see 3 results printed out this time: 32, 392, 843.8. And let's add one more for another run and do what's on the slide on the right. Fred. What's the Fahrenheit of Fred? And this time what we'll see when we run it, we get the values that we'd expect. Okay, the 3 values are printed out, but then we get this long syntax error, and it's saying, what? It's a little bit hard to read and understand exactly what's going on here, but it's telling us usefully that at line 8, so there's line 8, something has gone wrong. There was a computation that would try to be calculated, and there was a type error. Can't multiply sequence of non-int by float. And what's happening here is we've passed in that something that it's the wrong type of data to do this computation here. Okay. So once more, what's happening in this program when we run it? The Python engine starts at the top. It just processes these statements one by one, and it looks and it says, well, first off, we're defining a function, and this is the body of the function. It adds that function to the dictionary. It now knows that the name Fahrenheit refers to a function that's stored on the computer's memory, and that function has the following body. So that's the things that are executed by that function. Having defined the function, it then goes on and says, okay, now I've got some other statements to execute. I've got to print the results of calling Fahrenheit and passing in the value 0. So it does that statement, and that results in 32 being printed out. Then it goes on to the next statement, then the next statement, then the next statement. So the Python engine simply mechanically follows through from the top of the program to the end of the program, running through these statements one by one. Okay. So I mentioned earlier that this thing degrees f is a local variable. Okay, so a local variable is a variable that's defined within a function, and it only exists while that function is executing. Okay, it goes into a new dictionary, and that dictionary is restricted, if you like, to that function while that function is running. So the dictionary exists only while the function is running. Once the function has finished running, any local variables that were defined but within that function disappear. They're no longer available. We use the term scope to describe the regions of the program that can see any particular variable. So the scope of the variable degrees f is local to the function Fahrenheit. When do we use functions? We're going to be using them always. They're a primary building block for computer programming. In fact, the art of computer programming is essentially the art of breaking large problems down into a series of smaller problems, each of which is solved by a smaller function. our functions are going to be well tested and debugged. So we're going to be certain that they work before we include them in our program. Most functions will be fewer than 10 lines long, so they're very small little units of our program solution. And in 121, we're going to prohibit any function that's longer than 40 lines. So small, well-tested, well-defined and specific purpose. That's the art of good programming. One more thing before we finish today is that functions in 121 and in professional programming should always have a docstring that carries some documentation associated with the function. So we've broken that rule in our little version of Fahrenheit over here. So what we should have is an additional comment that describes what the purpose of the function is and what's it intended to do. So we'll add a little docstring here, converts a given Fahrenheit temperature to Celsius. So what I've done here is add a docstring, which is an English description of the function, surrounded by triple quote marks at each end, triple quotes to begin and triple quotes to end. And what this does is it carries meaning to the Python engine and it documents the function. So if I get rid of my syntax error here and I rerun this program, not only does the program run successfully, but I now have documentation associated with the function Fahrenheit. So if I type help Fahrenheit, I'll get the documentation available to me. So it's automatically documenting the function converts a given Fahrenheit temperature to Celsius. So we're wanting you to get into good programming habits straight away. So we're requiring that you create docstrings for your functions. So that's the beginnings of programming in Python. Next time we'll do some odds and ends to finish off week 1. Thanks.